Okay, so now we're looking at 7.4, which is ellipses. And once again, the key element here is that we're going to get the formula for this in just a minute here, but just to describe a few of the pieces involved, if we have this two distinct points, F1 and F2, there are two focus in a um, ellipse. And the ellipse, as you can tell, is somewhat oval. So what we've got is a string from each of these that has a certain length on it. And what we used to do in the old days, we'd put a pin here and a pin here and a string in between them. And then we could just draw our oval because that length of string never changed. But it would slide, and at different points, one side was longer than the other and vice versa. So that's the way these are set up. So they're called foci because there's more than one. Okay, and the distance d1, d2 add up to the same amount all the way around the circle or the ellipse. Now, the question then becomes, how would I plot one? And so they need a formula. So we'll roll down here. Here's our formula. For positive unequal numbers a and b, the equation of the ellipse with center h comma k is a and b are lengths of axis, and it's a little more involved. So right now we're just interested in what is the formula. So hk is the center of the ellipse. We're going to have two foci. And the lengths of the A and B are the lengths of the axis. So you would fill in your formula and then plug in x's and get y's, etc., etc. Now, an ellipse is not very far from a circle. And here's what you would see if you were to convert that for a circle. You'd see the same h comma k that we had as the center, but now a and b would be the radius. They wouldn't be two different things, they'd be the same thing. So therefore it would be a circle and not a ellipse. Now, none of this asks us to do much with things, so that's why I'm not going to make a big deal out of each phase of it. I think that we need to just look at that formula and see if we can plug in some values and get it to work. You notice here in the text, they don't spend a lot of time with it either. Okay, so I'm going to jump over to the last section, 5, which is hyperbolas. And now what I like to think of here is that the hyperbola is really the ellipse split in half like an egg and then turned in opposite directions. So given two distinct points, they're two focus points again, a fixed distance d, a hyperbola is going to be hyperbola. It's going to be a set of all points in the plane such the absolute value of the difference of each of the distances from f1 and f2 to x comma y is d. So in other words, these distances stay the same all the way through, but it's differences instead of sums. So there's your key fact. Differences instead of sums. Ellipses were sums of the distance. And here we are talking about differences. So coming on down, there's a lot of little vocabulary kinds of thoughts. This is how we normally draw them. We figure out what these axes are. These axes are the same axis A and B type of idea that we had in the ellipse. And what you do is you figure out what that rectangle must be from what your axes are, and then it becomes a guided rectangle, in that you draw through the corners, and those produce asymptotes that those lines can't cross. They get very close to but can't cross. So these are issues that are handy to have. Okay, now with this, there's two formulas this time. The standard equation of a horizontal hyperbola is x minus h over a squared minus y minus k squared over b squared. Okay, so this one is horizontal. It's opening to these two bowls open up right and left. Okay. Now the vertical one opens up and down, and look at the slight difference. That's why they write them side by side. Now in front is y minus k over b squared minus x minus h squared over a squared equals 1. So looking at where your stuff's positioned in it, you can tell whether it opens up and down or side to side. Okay, once again, there can be some detail work, but essentially all you need is the formulas. And they do some graphing, but I don't believe we ever touched on any of the graphing in this. Okay? So, let's just say for the moment that we have covered that, and make sure you have those equations